Hello, sixth graders, and welcome to 5.4. In Chapter 5, we're still discussing ratios and rates, and Section 4, more specifically, is comparing and graphing ratios. All right. For our learning target today, it is I can explain how to compare ratios and unit rates. I'll say with unit rates, it's really handy to be able to convert these because at some point in your life, I'm guessing you're going to have to find the price per one of something, price per pound, or something along those lines. And it's definitely going to help you in terms of being cost effective. All right. So we'll go through a few examples today, and I think you'll catch on rather quickly. It says comparing ratios, for example, one. You mix 8 tablespoons of hot sauce and 3 cups of salsa in a green bowl. And you mix 12 tablespoons of hot sauce and 4 cups of salsa in an orange bowl. And it wants to know which mixture is hotter. Okay. So um, let's use a ratio table to determine like a similar mixture or ratio so that we can compare these two um, hot, I guess, mix of hot sauce and salsa. So let's start with the green bowl. Okay, in my green bowl, it's important to label this section. So here's my green bowl, and I know I've got a couple things I need to input here. Here's my table. So I've got hot sauce, and that's in tablespoons, which is big T in the cooking world. Is it its abbreviation? And salsa, which is in cups. Okay, and I start off with it says 8 tablespoons of hot sauce, 8, and for every 8 tablespoons of hot sauce, I have 3 cups of salsa. Okay, and for my other one, my other bowl, let me choose a different color here for my orange bowl. Okay, again, making another table to kind of will definitely help organize our thoughts here. We've got hot sauce, I'm going to abbreviate that, and we've got salsa. Okay, and I start off with 12 tablespoons of hot sauce and 4 cups of salsa. Okay, and I want to know which of these is hotter. All right. Well, right now it's kind of like when you're comparing fractions. You know how you have to have a common denominator to be able to compare them. Um, that's kind of what we're going to do here. So notice that in my mixture, in my orange bowl, I have 4 cups of salsa, and in my green bowl, I have 3. So we can't really compare because it's different amounts of salsa. So how hot is it? Well, I don't really know. So what I'm going to do is I'm going to get my cups of salsa to the same amount. So in other words, find a common um, multiple that these two I can multiply by both. And if you look at 4 and 3, well, if I make this recipe 3 times bigger and I make this recipe 4 times bigger, I'll be dealing with 12 cups of salsa in each recipe. So if I multiply my cups of salsa by 3 to get me at 12 cups of salsa, and I multiply my hot sauce, if I multiply my salsa by 3, I have to multiply this by 3 as well. So that would give me 36 tablespoons of hot sauce for this recipe. For my green one, again, I'm going to multiply this by 4 so that I have 12 cups of salsa. Now I can compare 12 cups to 12 cups. And in my hot sauce, well, if I multiply this recipe by 4, I need to do it multiply by 4 the hot sauce as well. 8 times 4 is 32 cups. So now you see we have the exact same amount of salsa, In the green bowl, I've got 12 cups of salsa. In the orange bowl, I have 12 cups of salsa. What's different? Well, in my green bowl, I have 32 tablespoons of hot sauce. And in my orange bowl, I have 36 tablespoons of hot sauce. So I've got the same amount of salsa, but 4 more tablespoons of hot sauce in the orange bowl. So which mixture is hotter? That would be the orange bowl is hotter. Okay, again, that's because when they have the same amount of salsa, the orange bowl has more hot sauce. All right, so it's making this ratio table can just be a great way to organize your ideas. Right, next up is comparing unit rates. So remember, a unit rate is per one, and a lot of times it's getting your denominator to 1. Okay, so in this case, I start off with a couple different examples of dog food, and I need to find out which one is the better buy. This is definitely a real life example because you're always going to the store and seeing different quantities for different prices, and it's going to be to your advantage someday to find the cheaper one, as long as the quality is the same. All right, so I've got a 20-pound bag, it looks like. So a 20-pound bag. I'm going to abbreviate pounds as LB there. And I've also got the 30-pound bag. Okay, and again, I'm going to make a ratio table here to organize my ideas. And I'm talking about cost, and I'm talking about food, and the food is in pounds, so LBS, and the cost is in obviously dollars. Okay, and it tells me for the 20-pound bag, it is $17.20 for 20 pounds. And for the 30-pound bag, I have, again, I'm going to abbreviate, so I'm just going to cost and food. It's in pounds. I have $25 and is it 20 cents? And that is for 30 pounds. Okay. And right now it's hard to compare these two because obviously this one's more expensive, but you also get more. But which one is the better buy here? Which one's the better deal? Well, if you find the unit rate and if you find out how much money it is for 1 pound, then you can easily compare them. So again, I'm going to 1 pound here. All right. Well, how did I go from 20 to 1? Well, to find a unit rate, all you need to do is divide your numerator by your denominator. So from 20 to 1, I divide it by 20. And I'll do the same thing for my top number. 1720 divided by 20. Okay, look at these two numbers. I'm taking a smaller number dividing by a bigger number. My cost should be less than $1 per pound. Okay, and similar to here, to go from 30 pounds to 1 pound, I divide by 30. So I'll do the same on the top. And then you have a similar situation where smaller number divided by a bigger number, I should come up with something that's less than $1. Okay. At this point, now the skill that I'm most concerned about is how to set up these rates. So I'm okay for like this example if you'd want to use your calculator. If we're not working on dividing decimals and the key is more working on unit rates, go ahead and punch this in. We got 1720 and I'm dividing that by 20. I come up with 0.86, in other words, 86 cents per pound for this first bag. And the second one, I've got 25.20, and I'm dividing that by 30, and I come up with 84 cents per pound. So which one is the better buy? Now you're looking for which one is cheaper. Okay, so that would be the 30-pound bag. It's cheaper. A lot of times when you buy in bulk, it is cheaper. I'm running down on time here, so I'll pick up here in the next video with you on your own. Okay, if you have not yet, please pause the video and try on your own 1 and 2. All right, let's go over these quickly. Example 1, you mix 10 tablespoons of hot sauce and 3 cups of salsa in a red bowl. Okay, so I've got 10 tablespoons of hot sauce, and then I've got salsa, and I've got 3 cups of salsa. So remember, we got them to 12 so we could compare them. Well, multiply by 4, multiply by 4. That'd be 40 cups of hot sauce in this red one. So that was more than both the other ones. So this red one is going to be the hottest. This asks for the most mild. So looking back here, the one with the least amount of hot sauce would be the green bowls. Oops, sorry there. So the mildest would be the green, because I had the least amount of hot sauce per 12 cups of salsa. Okay. And then the next one says a 30-pack paper towel costs $48.30. So, and then a 32-pack costs that amount of money. Which one's the better buy? Well, just like before, I do your cost. So $48.30 divided by 30 versus the 32 packs. That was $49.60 for 32. Okay, just divide these. 48.30 divided by 30 would give you $1.61. And that would be for 1 pack of paper towel. And this other one, 49.60 divided by 32 would give us $1.55 per pack. So the better buy would be the 32-pack. Okay, again, it's cheaper for 1 roll of paper towel, and that's using unit rates to find that. All right, let me know if you have questions on those. And moving on now to the last example today, where you have to graph a value in a ratio table. Okay, and it says that a hot air balloon rises 9 meters every 3 seconds, and a blimp rises 2 meters every 2 seconds. Okay, complete a ratio table for each aircraft. All right, so we've got a balloon, hot air balloon, and we've got a blimp. And let's make ourselves a ratio table here. And this time I'm going to make a vertical ratio table just to kind of show you that it doesn't really matter what kind of ratio table you have. You can make them either way. And we've got time that we're talking about. And we've got meters or height, right? Okay, so our hot air balloon rises 9 meters for every 3 seconds. Okay, and our blimp, let's fill this in. I've got time and I've got meters. Our hot air balloon goes 7 meters every 2 seconds. Okay, fill in some data points here. All right, so here's our vertical ratio table. Well, how can I find some data here? Well, it's pretty easy to just multiply your data by 2, 3, and 4, and then you'll be able to compare them. Okay, so times by 2 will times my meters by 2 and my time by 2. I mean, for every 6 seconds, I've gone up 18, right? For multiplying by 3, 9 times 3 is 27 meters. 3 times 3 is 9. So 9 seconds gone by, I've risen 27 meters. And then times by 4 would give me 36 and 12. Okay, and I'll do the same thing for my blimp. So times by 2 would be 14 and 4. Times by 3 seconds would be 21. Times by 3 seconds would be 6. And times by 4 would be 28 and 8. Okay. And now I'm looking in my data where I can compare something and see which one rises faster. Okay. Well, let's look to see if we ever have anything that matches up. 3, 6, 9, 12, 2, 4, 6. Okay, so 6 is common. So as 6 seconds has gone by, my balloon is at 18 meters and my blimp is at 21 meters. Okay, so which one is higher? Well, that would be the blimp. And we found that because as 6 seconds gone by for both of these, the blimp is at 21 meters and the balloon is only at 18. Right? And then it asks us to graph this for letter B. Graph the ordered pairs, time, comma, height in the tables. And what can you conclude? All right, so let's use two different colors here. For the balloon, I'll use green. So time height after 3 seconds, it was 9. What are my other points? After 6 seconds, it was 18. 9 seconds, it was 27. And 12 seconds, it was 36 meters. And for my blimp, I'll use red here. And my different ordered points would be 2, 7, 4, 14, 6, 21, and lastly 8, 28. Let me just label my balloon over here as well. Okay, and now I need to graph that. Well, a lot of times it's good to label. So what am I talking about? I guess you could say rising speeds, how fast each one of these are rising. On the side here, I'll put my height. It's usually a good representation is when you're graphing height on the y-axis. And then on the bottom, as time goes by in seconds. Okay, and I have to make my axes here, so it's kind of hard to make them straight with my tablet here, so I'll do my best. Remember, this is the x-axis and this is the y-axis, is the vertical. My height is in meters. Forgot to label that. Okay, and then I'll graph each one of these. So my balloon is 3. Oh, okay, I'm not going to be able to go by ones here. Look at my data. I don't want to be going up 36. So what's something that I feel comfortable going by? Well, my height. I guess I could go by 4s. Looks like my highest number is 36. So 4, 8, 12, 16, 20, 24, 28, 32, 36 would be right here. And in my seconds, what kind of time am I dealing with? It looks like my X numbers are relatively small. Remember my first number is my time, so I could just go by ones. It is okay to go by different amounts of time as long as you stay consistent. So here I'm going by ones on the x-axis, and on the y-axis I'm going by 4s. That's just fine to do, right? So as 3 seconds goes by, I've risen 9. So here's 8. I'll go up one more, a little bit. Oh boy, hopefully that doesn't erase. 6, there it goes. 3, 9, let's see. There we go. 6, 18, so 6, just short of 20. 9, 27, so 6, 7, 8, 9, up to 27. Here's 28. Okay. And then 12, 36, 10, 11, 12. And then up to 36. Okay. And I started at 0. Connect my dots to the best of my ability here. Again, you could probably use a ruler. And then I got to graph my blimp in red. 2, 7, so over 2, up 7. I'm running out of time here, so it looks like I will continue here in the next video. Okay, so 2.7 was my first point. So right around there, just shy of 8. 414 over 4 up 14. 621. So over 6 up 21. So just above 20 here. Please don't erase. And lastly, 828 over 8 up 28. Okay. When I graph this, you'll see that the red line is above the green line. Okay, so when it says, what can you conclude about this? Well, since the blimp has a steeper slope, that means that it's rising faster, which is the exact same thing that we found when we made ratio tables. Okay, so kind of showing you that you can either look at a graph or use a ratio table and you'll get the same type of information. Okay. Go ahead and pause the video for the last on your own here. Right, it says the blimp rises 6 meters for every 2 seconds. How does this affect your conclusion? All right, so now for every 2 seconds, it's gone 6 meters. So 2 seconds, it's gone 6 meters. Okay, how does that compare? Well, if we got this to 6 seconds again by multiplying by 3, multiply this by 3, it would be 18 meters. What do you notice about these two? Well, now they're the same. As 6 seconds has gone by, they're both at 18 meters. So it would affect our conclusion because the rates are now equivalent. So they would be rising at the same rate. Okay. Now they are rising at the same rate. Okay. Let me know if you have a question on that one. All right. So a little bit longer than usual, but quite a few new things here in this video. Please let me know if you have any more questions, and I will do my best to explain it. Hope you have a good rest of your day, and until next time.